Good day, everyone. My name is Loïc Chamoy. I'm Business Development Manager for Energy Storage and Hybrid Systems at Wärtsilä. I've been working with Wärtsilä for almost 10 years now, and I've been involved in numerous mining projects over the world. And I'm extremely happy today to share a bit more about these very interesting topics, microgrids for mines, share about our own experience, and also what is, according to us, the key to the success of a microgrid operations. Decreasing the cost of power generation, decreasing your mining costs, increasing the share of renewables into your power generation, and moving to a more sustainable mining are topics which have been extensively discussed over the last years, and especially at this very same conference here, Energy and Mines. The good news is that today we are also able to share some insights from constructed projects, from projects or which are under construction. And some of those slides, some of those business cases have turned into execution, actually. What did not change over the last years is actually your main criteria, the most important things when it comes to microgrid operations. The first one being that you need reliability. So any outage in the power generation can cause huge lost revenues and can cause damages also to your mining equipment. So reliability should and has remained and should remain the number one priority for any microgrid operation. The second thing is that there is a constant need of decreasing the cost of operations for your mine and decreasing the cost of power. So we're going to see, what are the means to do that and the most effective way to achieve that. And also, we need to move to a more sustainable operation to reduce the fuel consumption, to reduce the greenhouse gases emissions. And I'd like to share a bit about our own experience as Wärtsilä in the mining sector. So Wärtsilä has more than 2 gigawatt installed power capacity at mining sites and 200 megawatt of that in Australia. And over the last years, we have also integrated some new solutions to those mining sites. So first example is the Essakane gold mine in Burkina Faso, where we have constructed a 15 megawatt PV plant to be integrated into an existing genset plant. And this PV plant was constructed for Total Eren, the IPP, and themselves they are having an offtake agreement with IAMGOLD, with the mine operator. This PV plant, as a fuel saver, enabled to save 6 million liters of fuel per year, and that's equivalent to 19,000 tons of CO2. If we want to take this microgrid and operations and the renewable integration to the next level, well, integrating energy storage then is the natural path. And actually, we do have a project in construction in Mali at the Fekola gold mine. The owner is B2 Gold, and Wärtsilä is delivering a 15 megawatt hour energy storage system and the energy management system. And this energy management system will also integrate 30 megawatt PV power and also 60 megawatt of thermal power. And it's important to say that those systems are not subsidized. So the falling cost of renewables also and the falling cost of battery storage enabled to have very shorter and shorter payback time for those systems, that basically the business model of having renewable or energy storage as a fuel saver flies by itself. And especially for energy storage, we have witnessed payback times as low as 2 to 4, 5 years. Of course, it's very depending on your site location, what's the cost of your fuel. But today, this is the main difference to what was the state of the projects of this hybrids project a few years ago. And if we have a look at what a hybrid system looks like, so here is a representation of a hybrid system on the island of Graciosa in the Azores. And as such, it's not a mining site, but they have exactly the same constraints, whether it's an island microgrid or a mine microgrid. Basically, you need to have a huge reliability on your power system, and also you need to have the lower cost of generation. So that's pretty easy, these two key parameters. And why is it a kind of a complex system still? Is because you are integrating different assets, and each asset has its own operating constraints. So for example, let's take the thermal gensets. You have, for example, the minimum load to consider. You have the ramp rate capacity. You have the different efficiency, starting time, and several others operating parameters. Then on the renewable side, you have to cope with the intermittency, the ramp rate up and down, which can happen, unforecasted. You can have the trip of an inverter, and so on and so on. And still, with all of these constraints, as an operator, what you'd like to see is just a stable operation. And it's just someone who managed to integrate all of this and dispatch your power in a very optimized way. And according to us, it's the key here. It's one of the key to have a successful and also optimized microgrid operation is to have an EMS, an energy management system, which is actually crunching all those constraints, which is taking load forecasting for renewable, which is taking load forecast for energy consumption, in order to have still deliver this extremely stable frequency, and in order to maximize the renewable penetration. Because in the end, the more renewable you are able to integrate, well, the less fuel you'll be consuming. And if we have a look at the value of the EMS as such, is extremely small. I mean, on an overall hybrid project, the value money-wise of the EMS is extremely small. The liabilities are very high for this EMS because it's actually the EMS who is responsible for the whole performance of the asset, of the whole hybrid plant. If we have a look at the systems which have the hybrid systems which are installed now in operation or in construction over the world, well, we still see that the renewable penetration is somewhere in the range of 20-25% top, but not more than that. And of course, this number will increase over the years. But today, the reality is still that most of your generation costs arise from your thermal plant, from your gensets. And in order, well, that may sound like a kind of basic advice, but if you want to save money on your generation costs, then having high efficiency genset is kind of the easy way to go. So let's imagine you have a fleet of gensets with a low performing efficiency, like below 40% or so. And you switch to picture yourself now having 43-44% net efficiency. Then this 10% fuel efficiency which you have, this 10% difference is also translating directly 10% on your fuel bill. You have 10% less on your fuel bill at the end of the year. And actually, Wärtsilä developed a modular system integrating those medium gensets, medium speed gensets, with high efficiency, but also very low life cycle costs. And this solution, called the modular block, is extremely scalable. And also because it's it has a high degree of prefabrication, it's very fast to deploy on site. So it will be deployed for the first time on the Sayama gold mine in Mali for the owner Resolute Mining, based in Perth. And it allows Resolute Mining to basically install the power which they need at the beginning of life of the mine without considering too much any projections over what they would need in 2, 3, or 10 years. Basically, they install what they need now, and they are able to easily expand the thermal side of the power plant as time goes by and as their need is increasing. So we have the same here, same scalability for thermal plant as what we have for energy storage by increasing inverters and modules, or for a PV plant, for example, by increasing also the amount of PV modules. So in our view, a powerful EMS, which is able to guarantee the stability and also the high penetration of renewable, and also a highly flexible, scalable, but high efficiency gensets are to us two keys to really decrease the cost of your microgrid operation and also decrease your greenhouse gases emissions. I hope you enjoyed this presentation and you had some good takeaways. Thank you very much for listening. The whole Wärtsilä team remain here available during the conference, and you can contact us afterwards as well. And we'd be very happy to kick off some good discussions around your microgrids, your challenges, the difference you have on your operation. And please feel free to contact us. I wish you a good conference for the remaining presentations. Thank you.